All right, everybody, welcome back to class. In today's class, we're going to be discussing about database because it's also one of the skill that we also need to have. And of course, we need to understand the purpose of database and how it works. All right, so today we're going to be explaining, all right, databases, the different type of databases, and why it is important for us as DevOps engineer, all right, to know how to set it up, and of course, the types of database that we have available. So we're going to be looking at basically, SQL and of course, and the NoSQL database. That's more like the two types of database that we have. Okay, so let's get into the conversation of today. Now, basically, databases are used to persist data. All right, that is one thing that we must understand very clearly. All right, so databases are what? They are used to persist data. All right, with database, you can of course update a record, create a new record, delete a record. But the most important thing that we need to understand is that it is used to persist data. All right, so that is very, very important for us to understand. Now, number two, databases are crucial in software development. All right, they help us to power applications that require efficient data. All right, handling. Now, we interact with different websites every day. All right, we go to different website, Amazon website, e-commerce website, maybe a portal is, a school website and all of that. And then, of course, we create different applications, every now and then. Now, all of these applications, for example, if you're seeking admission to a university, you go to the university's website, you maybe sign up on their website. All right, there are a couple of forms that you'll have to fill. Now, all of the data that you enter, all right, on that website is actually being persisted in the storage. So in this case, the storage is referred to as what? As a database. Now, that is why when you log out of the site and you log in again, you will realize that all the things that you entered, right, you were still able to recover your data. And in some cases, sometimes you don't even finish up the form, right, at one go, right? You basically just stop at some point and then you log out and then you sign in data when you have the time. And then you just discover that you just have to continue from where you stopped. So all of the data that you entered previously before you left, all right, you just basically just continued from that point. So basically, the database is in, right, helps us to basically persist that data such that every time you log in into your portal, your records are still there. You can still update your record. If there's anything you want to modify, you can modify. If there's any record you want to delete, you can delete. And of course, all of these things are handled by the database. So we must understand, that the one critical thing that database helps us with is that it helps us to persist, all right, data. Very important for us to understand. Now, developers need database for local development. All right. So for those who are developing applications, all right, they need database actually for their development because they are building an application that probably is going to have to interact with the database. Okay. So in order for them to test the application to see how, all right, the application is going to handle the data, is going to send data to the database, what do they do? In some cases, they can set up a database, all right, on their own local system. Okay, so for example, you have the developer, all right, and then the developer can have a database, all right, on their local machine. So everything that they do, they can use that database to just test, all right, how the application connects with the database. And if there are any kind of error, all right, they quickly see that and then they are able to correct it. Now, another thing, apart from hosting the database locally, is that they can also access, a database remotely. For example, if you're building in the cloud environment, you can have, of course, you're going to have different environments, right? You're going to have development, test, and prod. So in a development environment, you can have a database that everybody can use to basically do some kind of testing, right? So and on each of the database, you can have different databases, and then of course for each of the database, people can create their tables and all of that, that they need, right? So a developer can also access that. So basically, it doesn't have to host the database locally. You can leverage, all right, the one on the cloud, right? As much as it has connection to that cloud and it has all the necessary credentials, it won't have any issues accessing the database, all right? Now, let's go ahead and understand how does our application actually connect to the database, right? So I have an application, that application needs to write to the database, all right, and then somebody needs to read from the database through the application. So how does this connection, how does it work between the application and the database? Now, database connectivity is programmed as part of the application code. So what do I mean? Okay, so if you have a piece of code, for example, you might be developing in Java, all right, for example, right? Now, the credential of that database and the database endpoint is actually packaged together inside of the code. So an example of that, all right, will be what we have here, right? So an example of that is going to be this. So for example, this is a Java application code. All right. So inside of that code, you're going to have, all right, a script, all right, or a file dedicated to handling, the database connection. All right. So you have your database connection right here, and then you have your database username, the URL, and then the password. So everything is actually part of the application code. Okay. And also, if you're using a Node.js, for example, to build your application, all right, this is a snippet, all right, of what it looks like. Okay, so you have your credentials, you have your username and everything, and the database endpoint, everything is part of your code. Okay, now one of the things that we must be careful about is that database endpoint and credentials should not be hard-coded. All right, it should not what? Be hard-coded. All right, it should not be hard-coded. So hard-coded basically means that, your database connection, the credentials should not be in plain text inside your code. Because, you're going to check in this code into your Git repository. That means anybody that has access to that repository can actually see your username, your password, your database endpoint, and that is a security risk. Okay, so when you are trying to use, all right, a database with your application, what is advisable is that you can use things like, for example, AWS parameter store. All right, so you put your credential on the parameter store and then you reference, all right, that particular credential in your code. So what you have in your code is just going to be a reference, all right, to that, credential. So in other words, the credential is external. All right, it is not part of your application code. It is external, right? So you can have it in parameter store. There's also the secret manager on AWS, all right, that you can use to store, all right, your credentials. So it is external, right? So in your code, the only thing that you're going to be doing in your code is basically just to reference that particular location. And then by the time your application is being built and is being executed, all right, it's going to fetch, okay, the credential from that, remote endpoint. Okay, so that's the way it works. So again, database endpoint and credentials should not be hard-coded, all right, in your code, and then you should not check in your credentials to Git repository. Okay, don't make that mistake. Now, moving on, let's talk about database types. Of course, we have different types of database. Okay, remember, all right, in the first slide, we talked about the SQL database, we talked about the NoSQL database, and one of the things that we want to do is to understand the difference between the SQL and the NoSQL database. But of course, we can't understand it if we don't also understand the types of database, all right, that we have available. Okay, so let's get into the types of database that we have. Now, one of the things that we must also understand is, why do we have so many databases? How are they different from one another? And which one should I use for my application? So these are questions that I'm sure some of us would want to ask, all right? And perhaps you need answers to this. And of course, we're going to be answering them, all right, in subsequent slides. So why are there so many? How are they different from one another? Which one should I use for my application? So the first database we're going to be looking at, the first type is what you call a key value database, a key value database. Now, an example of a key value database is you have your Redis, your Memcache, or ID, and then you have your etcd. Right? So etcd is Kubernetes storage, okay, that you use for your Kubernetes. So these are key value database. Now, what does it mean by key value? What do we mean by key value database? Now, if we look at this diagram here, we have key 1, key 2, key 3. So basically, data are stored in a key value pair. So when you want to access, all right, a value, you basically reference the key. All right, so the key points to the value, all right, just like we can see on the screen. Now, one of the beautiful things about this kind of database is that they are very fast. Okay, they are very fast database, and one of the use case for them is that they are used for caching. Okay, you can use it on top of an actual database. So if you have a MySQL relational database, for example, you can put a Redis in front of that MySQL, all right, just to catch, all right, content, so that any traffic that is coming directly to your database, if that object or if the resource is already being accessed earlier, right, that means it's been cached in your Redis, and then from Redis, it can be served, all right, to the client. So that will reduce the load, all right, on your actual database. So they are very fast and they are useful for caching. Another thing that you can also use them for is, it is useful for message queues. All right, for example. And one thing that you need to know about this type of database is that they are what you call in-memory database, right? Which means all of the data that they store is actually stored in memory, not on the drive. All right, it is stored in memory. So which means it will have what you call a limited storage. All right, we've talked about being fast. All right, and so one of the downsides to this kind of database is that it is limited in terms of storage, because all of the thing that is stored, that they catch, all right, is actually stored in memory, not on the not on the actual drive. Okay, and one of the things also about this type of database is that you cannot use them as a primary database, right? It can be your primary database, okay, for your application. So the use case is for maybe caching, all right, for message queues, because of the efficiency, all right, in serving, all right, requests and all of that. All right. So let's move on to the second one. So the second one is what you call a wide column database. A wide column, all right, database. Now, example of a wide column database, we have Cassandra, we have Apache HBase, and we have Google Bigtable. All right. Now, a wide column database is actually used, all right, to, when you are dealing with applications that generate a lot of data, when you have a lot of data that you want to, all right, work on. For example, you can use it for what you call a time series data. Okay, so basically, a wide column database, that kind of database that is useful when it comes to handling things like your big data, all right, and you have a lot of data that you want to process, you want to query, manipulate, and all of that, right? A wide column database is useful for that use case. All right. Now, a wide column database is also a key value pair kind of database. All right. The only difference between the wide column and the key value database that we saw earlier is that the wide column database, all right, is still the same key, but the values are divided into multiple columns. All right. The values are divided into multiple columns. So that's just the difference, but it's still a key value, all right, kind of database. But for this kind of database, it is used basically for big data kind of operations. All right. It is also schemaless, right? Schemaless means it's also NoSQL. All right, it's a NoSQL database. All right, it's not a SQL database. All right, as well. The key value database that we saw earlier is also a NoSQL, all right, database. So this also is also a NoSQL, all right, database. Now, one of the advantages of the wide column database is that it is scalable, all right, which means it can scale, all right, to, just like you can scale your instances, you can, increase your, instance size and all of that. So this is also scalable, which means it can handle, all right, more load if the need arises. All right, it is useful for time series data, which means if you have a lot of data set that you want to work on, it is a database that you need to consider. It is also useful for real-time analytics, all right? Real-time analytics on big data. It is also useful for that. One of the downside is that, there's a lot of issues when it comes to data modeling, right? Data modeling in the sense that it is not a structured database, right? So querying the database will require some kind of skill set and all of that. So in terms of data modeling, there may be some kind of downside to it because, it's a large database, all right, and then it is not structured, it is unstructured, right? So which means it doesn't follow, okay, the normal SQL structure, right? So querying the database, manipulating the data, and all of those kind of things, all right, might require some extra skill to be able to use it. So, and of course, that will also affect how you can query, all right, this kind of database. So in terms of querying flexibility, all right, it is not so flexible when it comes to querying data, all right, in a wide column database. Okay. All right, so the third one that we're going to be looking at is what you call a document database, all right? A document DB. So what is a document, all right, database? Now, we have quite a number of, document database. So let's take a look at the types that we have. So for document database, you have your MongoDB, you have your DynamoDB on AWS, and you also have the Amazon Document DB, and then you have the Couch, all right, DB. Okay, so let's take a look at the document database. Now, the document database is also a NoSQL database, and it also follows the same key value, all right, pattern as well, like we've seen in, the other databases that we consider. So let's take a look at some of the advantages. So one of the advantages that it offers faster read, right? It is very fast when it comes to reading that database, all right? And you can also use this kind of database, all right, for as a primary database. And as a matter of fact, these kind of database are actually used for mobile applications. Okay, they are used for game apps. All right, and of course, for some content management use cases, website, you can also use a document DB. All right, as the primary database. Okay. But one of the downside is that it is slower when it comes to writing to the database, all right, and then in terms of standardization as well, because it is not structured as well. It is also schemaless, right? So in terms of that, and of course, it doesn't follow the ACID nature of the SQL database. So that can also be some kind of complexity, all right there. Okay. So moving on, let's talk about the relational database. Now, the relational database is more like the oldest. It's been around for a long time before even all these other databases, all right, came into use. So relational database has been around for a long time. And of course, we have this, I'm sure some of us have heard about, some of these names before. You have your MySQL, there's the PostgreSQL, there's the Oracle database, and also you have your Microsoft SQL, all right, server. All right, so it's the oldest database around, and of course, it has a lot of use cases, and it still continues, all right, to be relevant even today. Okay, so if you look at the relational database, you will see that it is a kind of database that, of course, has different relationships. And in the database terminology, you say it supports what you call joins, which means you can actually connect different tables together. All right, this table can reference that table, this other table can reference that table. All right, there's a link, all right, between the tables. It's just like when you go to a school, a university, right? Somebody has an account on the university portal. All right, that single account, the person has access to the library, the person has access to let's say the cafeteria of the university, the person has access to the bursary in order to make the payment. All right, of course, their school record, all right, is also available and all of that. Now, all of this data that I mentioned probably will be in different tables, right? But this user can actually log in with his own credential and then is able to access, all right, all of these different tables and of course get data, all right, from them. Okay. Now, one of the advantage of the relational database is that it is a structured database. Okay. Because it is not a schemaless database. That's what we mean by structured. So when you say something is unstructured, it means it is schemaless, right? Which means it doesn't follow any kind of pattern, right? You don't have to define any schema. Okay, so when we talk about schema here, we're basically talking about, you don't have to define any table. You don't have to define any row. You don't have to define, what kind of data you want to accept, whether it's an integer, whether it's a character, all right. You don't have to define maybe the length of character that you want and all those kind of things, right? But when it comes to a structured database, like the relational database, you have to clearly define the kind of data you want to store in the database. Right? So when you're creating your table, you're already saying, oh, okay, my ID should be varchar, all right, age should be integer, all right, this should be this, and then you specify the length of each of those characters. Okay, so that's what we mean by something is structured. So you can say it is structured, or you can say it is, of course, it is schema oriented. All right, so it follows that. Now, another thing also is that it uses the structured query language. All right, it uses the structured query language, which is SQL is a short, all right, for structured query language. All right, so it uses that. So which means when you want to query the data inside of these relational databases, all right, there's a language that you can learn, of course, that will equip you with a skill to be able to query and fetch data, all right, from these databases. And of course, it follows what you call the ACID, all right, property. All right, it follows what you call an ACID property. So that ACID property basically means atomicity, consistency, isolation, and durability. Okay, so let me take that again. Atomicity, consistency, isolation, and durability. Now, an example of ACID property basically is when you do a transaction on your banking app, when you send money to somebody, by default, the person should receive that credit in their account. And of course, the account balance should, of course, increase. Now, on your own end, your account balance will decrease. Now, if there was a network outage or something happens and then the transaction did not complete successfully, all right, because of the ACID nature of the relational database, right, that money will be reversed back, all right, to your own account. So the way it works is that it doesn't allow anything like half changes, all right? So which means it is either the changes are applied or the changes are not applied at all, okay? That is basically what it follows. So it is either the changes are applied or the changes are not even applied at all. So that's why when you send money to somebody and then there's a network issue, even if the bank debits you, all right, after some time, if you wait for some banks, all right, they reverse the money back into account immediately because the database is actually based on the ACID principle. All right. Now, but the downside to this database is that scalability. It is difficult to scale. Okay, that is one of the downsides to the relational database. Okay, and that is what actually gave birth to all of the different databases that we now have in the world today. Okay, now quickly let's take a look at some other databases, all right, that we have available in the market. Okay, now we have what you call a graph database. All right, a graph database. And an example of a graph database is, Neo4j and dgraph. All right, these two are actually graph databases, okay, because basically what they do is that they directly connect entities. Now, a use case for a graph database is a recommendation engine, right? Like your YouTube, for example, like your Google engine, for example. All right, they use this kind of databases, okay, to basically perform all of the operations, right? So that's what they do. So they call them a graph database, which means, all right, there's a link to different things, okay? This person is connected to this. For example, if you're following somebody on Instagram, remember, you're not the only person following that person. So there can be one person and then the person has 1 million followers, right? So that's plotted in terms of a graph, right? So this person connects to this person connects to this, right? For example, if you go on Instagram, for example, you see things like, you see the people following you, and then you can see those that you are also following. All right. So all of that data is actually plotted in form of what? A graph. Okay, this one is connected to this one is connected to this person is connected, all right, to this. So a graph database can help us to handle such data complexity efficiently, right? And then the last one is what you call a search database, all right, a search database. So a search database, like your Elasticsearch, it is actually used to search, for data. So if you're looking for data in maybe in any kind of movie, for example, you have a log data, all right, and then you're looking for something, all right? An Elasticsearch can be like a dashboard where you can aggregate all of those data and then create what you call indexes, all right, for each of the words, all right, that you're looking for. So Elasticsearch is one of those databases that can help us to handle, all right, that very efficiently. So to quickly recap, we have talked about different databases. We've talked about the key value databases. We've talked about the wide column. We've talked about the document database. We talked about relational database, graph database, and the search, all right, database. So these are the database types that we have, all right? We're going to be using some of them, all right, like the relational database. We're going to be building applications that, of course, we need to persist their data, all right, in the database. So thank you so much. If you have any question about databases, all right, do well to put it in the comment section and I would respond, all right, to your question. Thank you so much. Don't forget to subscribe to the channel. Don't forget to like and don't forget to share the video, all right, to as many people that would, that will find this useful, and of course it will benefit them as we grow together, all right, on this journey to become a DevOps, all right, engineer, all right. Thank you so much for your time, and I will see you in the next video. Thank you.